In 7.3, we're going to be using the formulas that we learned to write in 7.1. And now we're going to be finding masses and formulas and all kinds of new things. So first of all, with those chemical formulas, we can find formula mass, molar mass, and percent composition. It's going to be important that we know where we're getting the mass from. So the mass of individual atoms, remember, comes from the atomic mass on the chart. And we can see that here, and I've pointed those out with arrows. So helium's mass is 4.0026. Argon, 39.948. When you do these on your homework, we're going to round to 2 decimal places. Formula mass is taking a formula that you've been given and adding the mass of all the atoms in that formula together. And that will give us the atomic mass, or we'll be using the atomic mass unit for those formulas. So we'll look at water as an example. The first thing we have to do is determine how many of each atom we have by looking at our subscripts. So we have 2 hydrogens and 1 oxygen. We're going to find the mass of hydrogen, which I'm going to round it to 1. So that 1 times the fact that I have 2 hydrogens gives me 2. Then for oxygen, I've got a mass of 16 for oxygen, and we have one of those. So 16 times 1 gives me 16. And then I'm going to add my 2 and my 16 together to get 18 for my final answer. And the units here are atomic mass units. The next example, H2SO4. So we've determined how many of each atom we have. We have 2 hydrogens, 1 sulfur, and 4 oxygens. Then we're going to multiply however many we have by the mass. So hydrogen has a mass of 1, sulfur has a mass of 32, and oxygen has a mass of 16. All of those multiplied by how many atoms we had. And then we add all of those together. 2 plus 32 plus 64 gives us a mass of 98 AMUs for H2SO4. This last example here, CaNO32, we need to remember that this 2 outside the parentheses is going to take anything that's inside the parentheses and multiply by the subscripts. So we have 1 calcium, 2 nitrogens, and then 6 oxygens. So when we multiply those by our masses from the chart, we need to make sure we've multiplied by the subscript outside the parentheses. So we add those together and we get 164 AMUs for CaNO32. Now, we were looking at formula mass. Molar mass is calculated the same way. The difference is that formula mass, the units are AMUs. Molar mass is grams per mole. Now we're going to do a little conversion refresher because we're going to be converting in this chapter. So if we start with 76 kilometers and we want to get to miles. So we're going to do 76 kilometers. We'll do our multiply, draw our line, so kilometers on bottom and meters on top. And there are 1,000 meters in 1 kilometer. Now we need to get to something that we can get to miles. So we're going to go meters to centimeters. There are 100 centimeters in a meter. Centimeters can go to inches. So in 1 inch, there are 2.54 centimeters. And then in inches, we're going to go to feet. So 1 foot is 12 inches. And then we can go feet to miles. 1 mile is 5,280 feet. And now we're ready to solve. So remember, we multiply across the top and divide by everything on the bottom. So in my calculator, I'm going to type 76 times 1,000 times 100 divided by 2.54 divided by 12 divided by 5,280. And that gives me 47.2 miles. So one thing I really want you to focus on is whatever you start with goes on bottom in the next step. So we won't have any that are this long, but this is just to give you an idea and refresh your memory on how we're going to do this process. So molar mass conversions, we're going to do a few different types. So we've got mass to moles, moles to mass, moles to atoms or formula units, and then back, and then mass to atoms or formula units, and atoms and formula units back to mass. So conversions. So these are some things we've touched on before, but remember that your mass is always going to be in grams, and the grams are going to come from the periodic table, and that will always equal 1 mole. 1 mole equals Avogadro's number of atoms. And then the mass in gram is equal to a mole, which is equal to 6.022 times 10 to the 23rd atoms. If you don't have all of these written down somewhere, you might want to do that. So the first problem, what is the mass in grams of 2.5 moles of oxygen gas? They gave us the formula, and that formula is important because we're going to have to use it. So we're going to start off 2.5 moles. That's the number they gave us. We'll do our multiply in our line. So because we started with moles, moles goes on the bottom. And we're looking for mass, so that's grams. And we said that 1 mole equals the mass from the periodic table in grams. Oxygen, if you look it up on the periodic table, is 16, but we have 2 of those. So that's going to be a mass of 32 grams. So we'll put 32 in our grams spot. And so since we were looking for grams, now we're ready to multiply. So 2.5 times 32 is going to give me 80 grams of O2 for my answer. Now, if I had just done the mass of 1 oxygen and put 16 where the 32 was, this would have been incorrect. So make sure that you are calculating the mass of the correct formula. Uh-oh, it won't change. Here we go. Come on. All right, now we've got ibuprofen, which is C13H18O2. This is, it says, the active ingredient in most pain relievers. What's the molar mass of ibuprofen? So that just means it wants us to find the mass. So we've got carbon, C, and we've got 13 of those. H, we have 18, and O, we have 2. So if you use your periodic table, it's going to tell you that the mass of carbon is 12, the mass of hydrogen is 1, and the mass of oxygen is 16. And I'm rounding to whole numbers now, and like I said on homework, we'll do 2 decimal places. So we're going to have 156, 18, and 32. So we need to add all these together for a mass of 206 grams. We're going to need this in the next step. If a bottle of ibuprofen contains 33 grams, how many moles are in the bottle? So if we start off with 33 grams of ibuprofen, and I'm going to say IB just to designate that ibuprofen, we're going to put grams on bottom and moles on top. And we said 206 was the mass of ibuprofen, so that's going to go on bottom. And so now we're ready to solve. So we're going to do 33 divided by 206, and that gives me 0.16 moles for my answer. Uh-oh, I need to erase. technical difficulties, guys. All right, now how many molecules of ibuprofen are in that bottle? So we just said there are 0.16 moles. So 1 mole, we know, and we can say atoms or molecules or formula units. So 1 mole equals 6.022 times 10 to the 23rd molecules. And I know it's a pain writing out molecules, but if you try to abbreviate that, you're going to get moles. So be careful with those labels. So 0.16 times 6.022 times 10 to the 23rd is going to give me 9.6 times 10 to the 22nd molecules. How many moles of compound are there in the following? So I want to convert this to moles. So I first need to find the mass of NH42SO4. So I'm going to make a list of how many of each of these I have because there's a lot going on here. So for N, I've got 2. For H, I've got 8. For S, 1, and O, 4. So if I look up nitrogen on the chart, the mass is 14, so that gives me 28. Hydrogen's mass is 1, so that gives me 8. Sulfur's mass is 32. And oxygen has a mass of 16. And I'm going to add these all together. So 64 plus 32 plus 8 plus 28 gives me 132 grams. So I'm going to jot that up here. And that's the mass of NH42SO4. But we want to know how many moles do we have if we've got 6.60 grams. So I'm going to erase some of this to give us more room. So we're going to start off with what they give us in the problem. So they give us 6.6 grams, and we're looking for moles. So grams on bottom and moles on top. We know that the mass is 132, and so that's equal to 1 mole. And then all we have to do is 6.6 divided by 132. And that's going to give us 0.05 moles for our answer.